Start with the great name of Allah, who is the most beneficent and most merciful. The topic of today's presentation is speaker recognition using machine learning. We have completed this project in a group of 2 members named Parvez Ali and Manoj Kumar, and we have done this under the supervision of Dr. Gulsher Ali. So this is the outline that I will be discussing throughout this presentation, that is introduction, motivation, problem statement, literature review, aims and objectives, methodology, results, conclusion and feature recommendation, references. And so for the introduction, voice or speaker recognition is the ability of a machine or a program to identify the speaker or recognize the voice of the speaker. So AI specialists believe that each human being has a unique or a different voice print that can be used to recognize the speaker, which is known as speaker recognition or voice recognition. There are 2 types of speaker recognition. One is text independent and the other one is text dependent. In text independent, you don't have to say determined phrases so that machine recognizes you, while in text dependent, you have to say a determined phrase or a password so that machine or program recognizes you. There are already been trained a lot of algorithms on these kind of applications. One of these is YAMNet, a classification model that is being trained by TensorFlow, which is available on the internet. So for the motivation, why NLP? NLP is a branch of artificial intelligence known as natural language processing. So if AI claims that it is intelligent, then it must understand the language of human beings. It must perceive their language. And the other thing is that NLP is less costly and it is more efficient and less time taking. So if you want to hire someone in your office who is working like an assistant, then it would be much better and much cheaper to have a robot of NLP that do that kind of work. And we have chosen Sindhi language. So why Sindhi language? There are almost 47 million people around the globe who speak Sindhi language and 32 million people in Pakistan who are speaking Sindhi. Moreover, 24 million who speak Sindhi in Sindh. And the literacy rate of Sindhi is 60% all over the Sindh, and in rural areas it is 50%. So we can say that the literacy rate or literacy rate in urban areas is higher than the rural areas. And the literacy rate is measured using a primary pass. So it doesn't mean if someone has passed primary, he must be well aware of these applications which are used in English or some other languages. So for problem statement, there are applications that are used with voice classification like picture to voice, anomaly detection, forensics, security. So we are trying to build such kind of application based on Sindhi language. To our knowledge, there is no such kind of application that is being built using Sindhi language, and there's no such kind of data set that is being collected in Sindhi language. There is something else, that the trained deep learning models are very difficult to deploy on edge computings like microcontrollers or mobile applications, that we are going to solve this by deploying a model into an Android device or Android application. So for literature review, we have read some kind of papers in which most of the researchers has used MFCC, LPCC, spectrogram, this kind of features to find the spectral values of a voice signal. And they have used classifiers like HMM, hidden Markov model, Gaussian mixture model, recurrent neural networks, convolutional neural networks, and the data sets that they have used are available on the internet. And the recognition rate that they have given is changing from 50% to 99%, which varies because of the environment that they have used to collect the data. If environment is stressed or noisy, then the accuracy rate decreases. And if the environment is quiet or it is noise-free, then the recognition rate increases. And the speakers that they have considered are from 25 to 3,500 speakers. These are the aims and objectives of our project. One is to collect voice-based data in Sindhi and extract features from collected data or collected recordings. And then we have to train a deep learning model on collected data. we have to convert a trained model into a binary format or a flat buffer format, and then we have to deploy that flat buffer format model into an Android device. So for methodology, first step is to record voice or collect data. Second one is to extract voice features. And the third one is to train a deep learning model. Fourth one is to convert that trained model into a TF Lite model and then deploy it into a mobile application or Android application. And at last, we can do some live classification or recognition of a speaker. So for voice data collection, we chose 5 speakers, and the sampling rate that at which we recorded the samples was 16 kilohertz, and the bit rate was 16 kilobits. Length of each phrase or each sentence was between 2 to 3 seconds, and the language that we used was Sindhi language. And the format that we used to store the data was .wav format, and the hardware that we used to collect data was laptop, our laptop microphone. Software that we used was EaseUp Recorder. The total size of data that we got was 54.94 megabytes. These are some of samples that I have added in this presentation. And then we deployed or uploaded this collected data under a Kaggle environment. It is a online data science environment where we can train deep learning models or machine learning models and then test them. This is the data distribution, and data distribution is actually very important to look at the data distribution. As in machine learning, if data is overlapping or not distributed, then it is quite often that the model will not work or it will give a worse accuracy. So here we can see that most of the data is distributed or not overlapping. So we can say that this data can be used to train a machine learning model. So for feature extraction, first feature that we extracted was male spectrogram. Male spectrogram is extracted using fast Fourier transform. So we use a Hamming window. A Hamming window chooses a chunk of time domain signal from voice and then convert it into a frequency domain signal using fast Fourier transform. So when we have a frequency domain signal, then this frequency domain signal is again converted into a male scale signal. Actually, male scale is better with human beings, as human beings are good with 20 to 3 kHz of frequency for voice. So we convert this frequency domain signal into a male scale signal. And after converting this signal into male scale, we get this kind of image, which is fed to a deep learning model. So this picture is different for each sample, and on the basis of this picture, a speaker is recognized. Second feature that we extracted was MFCC, male frequency sequestral coefficient. The steps are same according to spectrogram. Here we use a Hamming window, and the chunk of data is converted into a frequency domain signal using Fourier transform. But the difference here is that at the end of conversion, a discrete cosine transform is used in MFCC to remove the sign trumps. In machine learning, if data is not correlated, it is really beneficial to train a good model and our accuracy increases. So for that, the MFCC uses discrete cosine transform at the end to convert the data. And when we have a frequency domain signal and we use this male scale, so we have to also convert a frequency domain signal into male scale, then we get this kind of a matrix, and the width of matrix depends on the filters that you use. There are total 31 filters in male frequency sequestral coefficients. We have used 13 filters, so we get 13 columns in our feature set, and this feature set looks like this when we pictorial or visualize it into a picture. So it looks like this image, and which is different for each speaker. The other feature that we extracted was chroma features. Chroma features are actually 12 semitones or chromas of a voice, which are described in musical industry as the 12 pitch classes. So we converted a frequency domain signal into 12 pitch classes, which was features used to recognize the speaker. And the spectral centroid is actually the mean or the most of data where lies. So if we have a spectrogram, then this white line represents the centroid or mean of the data where most of the energy of signal lies. The next one is spectral contrast. Spectral contrast is actually subtracting peak energy from valley energy of a signal, which gives us a spectral contrast. So if we have a power spectrogram or MEL spectrogram, we subtract its peak energy from valley energy, we get spectral contrast. So next step is to train a deep learning model. We choose sequential convolutional neural network, and its input shape was 468 into 168. Number of layers that we used were 5 convolutional layers or hidden layers and 4 activation layers, 1 max pool layer, 1 flattened layer, and a dense layer. We used a dropout of 0.3, and the trainable parameters were 222,510. The optimizer that we used was ADAM. The batch size that we used was 32, and the number of epochs that we chose were 100. And the testing accuracy in real-time environment, we got 86.4%. This is the training line or training curve of our model. So you can see that the accuracy of models is increasing as the number of epochs are increasing. And the loss curve, so loss of model is decreasing as the number of epochs are increasing. And finally, this is the confusion matrix, in which we can clearly see that only few of the test samples are recognized wrong, while most of these are correctly recognized. So we can say that this model is really recognizing good, or its accuracy is quite good. This is a process to convert the trained model. There are 3 steps or 3 ways to convert the trained model into a TF-Lite model. One is to convert using TF.Keras model. The other one is to convert using saved model. And the third one is to convert using concrete functions. We will be using saved model. Saved model, like we will train a model and save it into a .h5 format and then convert it into a TF-Lite format. So if we have converted our model using TF-Lite converter, then we can use that .TF-Lite format model into Android, iOS, or any Linux board like Raspberry Pi or in microcontrollers. So these are results. We used our model to deploy it into a mobile application, and we did a real-time testing in which we got good accuracy in real time at a quiet environment. So for conclusion, we collected voice-based data. We trained a deep learning model on collected data, and we converted that trained model into a flat buffer format for edge computing. And then we deployed that flat buffer format model into a mobile application. For future recommendation, I would say that the size of this data must be extended. If we compare this data with the datasets that are available on internet or in Kaggle, you will find that this data is quite small, so we should increase its size, and we should use this data or to perform other applications like security or forensics. And to make this model work in noisy environment, we should collect such kind of data or use signal processing to make this model accurate in noisy environment as well. These are the references that we used in our project. That's all. Thank you.